So welcome, everyone. The topic for today is provisioning vApps on Vblock with VMware vCloud Director, which was just announced this morning. So I want to just quickly take a poll. How many of you have heard about or know about what a Vblock is? Well, that's pretty good, about half of you. Okay, one of the things we're going to do, by the way, my name is Rupen Sheth. I'm a solutions architect for VMware, focused specifically on VCE solutions, as in supporting the VCE coalition. The Vblock is a product of that. With me here, okay, I can go ahead and introduce you. Okay, we got Mahesh Rajani, who's a senior member of our cloud services group and intimately familiar with vCloud Director. So the focus for today's session is really to try to take you through a complete stack in order to go through what it takes to provision a business service. And we've broken that up into two distinct components. The end goal is to provision a business service. You guys are already familiar with the virtualization stack in terms of what it provides. We'll touch on some of the new cloud, vCloud Director related components. I'll focus specifically on the physical infrastructure provisioning, because that's really an area where there isn't a lot of automation and management possible today. So that's how we've kind of broken it up. Standard disclaimer, because we do cover some products that are not yet released. Mainly, I'll touch on UIM 2.0. Used for physical infrastructure provisioning. Okay, so the agenda for today is broken up into two distinct sections. I'm going to focus on the introduction to Vblock, provisioning in a Vblock, as in doing all of the hardware infrastructure provisioning and management across the compute network and storage stack. Once we're done with that, I will hand it over to Mahesh, who will kind of take you through the virtualization and the cloud services stack to kind of complete the story around provisioning a business service all the way through. Okay. So let's talk a little bit about the challenge or the problem that we're faced with today. Data centers today are extremely complex. We have a lot of moving parts. Too much time and energy is spent today in terms of integrating and putting all of the pieces and components together, dealing with integrating the storage with the network, with the compute layer, making sure you have all of the right components, drivers, adapters, designing a complete system, all in all, to just make sure you have a platform and an infrastructure to host your business service. So too much time and energy is spent today in the nuts and bolts. So we certainly need to start thinking about a new way of making this available. And we'll talk about that a little bit. The way that's done is what's called the Vblock infrastructure packages. Okay, a Vblock is a product that puts the best-of-breed components from Cisco, EMC, with VMware into a complete integrated, tested system with known service levels, known capacity, known performance characteristics. So the idea is, it's almost like the analogy that I'd like to make is figuring out when you go out to buy a car, you need to know whether you need a 4-cylinder or a 6-cylinder, how many passengers you're going to have in it. Don't worry too much about the transmission and the engine and making sure everything is balanced and tuned. You're buying a car, you know how you want to drive it, you know how many passengers you're going to fit in it, and that's so kind of abstract yourself from the component level into thinking about the overall system, because that's the whole idea behind this. There are lots of other advantages by using the vBlocks. Obviously, instead of ordering 500 parts from 3 different vendors and trying to put everything together on your own, you have a pre-integrated, fully built system that you're purchasing. Okay. Rather than having 3 separate service contracts with Cisco, EMC, and VMware, there's one service contract, one support call. Okay. It's all about simplifying and making things more efficient for you. Okay. How are these available? We currently have 3 distinct SKUs or products, if you will, of types of vBlock. It's almost like knowing whether you need a sedan or an SUV or a different type of model. The vBlock 2 is designed for large enterprises, extremely scalable. It's for the most demanding workload needs. We'll talk a little bit about some of the components that are part of this. On the storage side, on the back end, it uses a Symmetrix Vmax. The other core components are pretty common from a compute standpoint, but it allows more scalability. Okay. vBlock 1 is kind of the mid-range system that uses the Clarion backend. And the vBlock 0 is designed to be more of an entry point system using a Celera storage backend. Okay. It's good for test dev, folks that want to start out and test the vBlock infrastructure. So these are the 3 basic types of vBlock that are available today. Okay. I'd kind of struggled whether I needed to include this particular slide in there because on one hand, I'm talking about abstraction and leading you down a path not to worry about the components. Then I thought folks really, it's a technical audience, they want to know what's in there. So I've got this in here. We're not going to spend too much time. I'll touch on some of the management components. We'll go through that a little bit later. But from a compute network standpoint, it's got the Cisco Nexus 1000V standard. So obviously the Enterprise Plus license is part of the vBlock. vSphere is a standard component. From a compute standpoint, there's the UCS chassis, which has, each chassis has 8 blades and what's called the fabric extender, which is a 2100 series, 2 of those, which then connect to a 6100 series, either a 6120 or a 40, depending on the type of a vBlock you have, all SCOE. From a core aggregation layer, it doesn't really need a Nexus 7000. Obviously, if you have some other infrastructure within your organization, this can easily plug into that. And on the storage side, I touched on the different variants that you have for vBlock 0, 1, and 2. Okay, just a high-level overview, and when you download this later, maybe a reference point for you in terms of the differences. Each one of the vBlocks has a degree of variability in terms of expanding compute or storage capacity. So the idea is that each vBlock, it's not fixed in a sense. It's not that you have to have X number of blades or just so much storage. You do have flexibility in terms of expanding compute or storage capacity to a certain degree. The idea is that you have a total, it's a well-balanced engineered system. So you're allowed to increase capacity in each one of these dimensions to a certain degree. You don't want to go crazy on it because otherwise you end up with this, what I like to say, a Ferrari engine with bicycle wheels, right? You want to make sure that your system, overall system, is well balanced. Okay. Obviously, from a converged network adapter perspective, you do have a choice of Emulex QLogic or Cisco's VIC, which is a virtual interface card. That's the Palo adapter. Okay. So overall, the Vblock provides predictable performance, capacity, and capability. The environmental characteristics are well known. You know exactly how much data center space you're going to occupy, the power requirements, the heat dissipation, all of the other data center characteristics that you would need to know. Those are also predetermined. It's engineered to be very fault resilient. So from a component level, it is designed with fault resilience in mind. So the idea, again, the analogy with cars, it comes standard with seat belts and airbags, right? So that level of fault resiliency is built into the vBlocks. Yes? The question is the power, cooling, and other environmental characteristics for the vBlocks, are they documented and published? I have a resources section towards the end where you can go to download the information related to vBlocks. Thank you. Okay, so a little bit on providing a flexibility and scalability on the vBlocks. So as I covered, the vBlock in itself provides the ability to scale. You can obviously add additional vBlocks of the same type or a different type to increase capacity. Okay. You can also expand either compute or storage capacity as needed based on your requirements to a certain degree. Okay. So that allows you a modularized approach to scale your environment. Okay. So that's just an overview on what a vBlock is. I'm going to touch on provisioning in a vBlock. So the idea here is to try to abstract ourselves from provisioning components and think more about provisioning different physical service level components. What I mean by that is both from a compute network and storage stack, let's not start thinking about just computing those components. We need to be able to pool those, each one of those tiers, just like we do on the virtualization stack. We need to start thinking about pooling even the physical components together. Okay? So the idea is to create your bronze, silver, gold types of hardware pools with different characteristics. So for example, your server pools could be grouped into different pools of servers that have different memory characteristics, or your virtual interface card could be configured with different number of NICs and HBAs depending on whether you're a bronze, silver, or a gold. From a storage side, just from a raw capacity standpoint, you're able to group those into storage tiers based on whether the type of drives they're on, whether it's SATA or fiber or EFD, for example, whether you provide a replication or the types of characteristics for gold versus not providing them for the bronze. So the idea is to start thinking about the hardware components also in terms of service tiers, and to abstract that and to be able to automate and provision that. So the way this is broken up is distinctly into two areas. I'm going to focus on the bottom layer, which is the physical infrastructure management. Mahesh will then continue and kind of complete the story with the top layer. Okay? So from a bottom layer, what we have is the physical infrastructure management and provisioning. Okay? So as I talked about grouping these into pools, the compute, storage, and network pools, there are obviously different element management systems that are available today. The orchestration and automation and management across all of these is done using EMC Ionix Unified Infrastructure Manager, or UIM. Okay? So UIM is going to provide all of the physical infrastructure orchestration and provisioning, again, grouping those into service tiers. It has the ability to manage multiple vBlocks. What I mean by that, if any of you have used UCS-based systems, the compute pool is managed by what's called UCS Manager. They are distinctly separate entities. UIM allows you to group and integrate multiple UCS managers together and to manage all of your pools within one dashboard. Okay? So orchestration for the physical infrastructure is done using UIM. Okay? The way that's orchestrated is by using different templates that then pushes it out to the compute network and the storage fabric. Okay. The dashboard, very briefly to what the dashboard for UIM 2.0 looks like. On the top left, you have the ability to select different vBlocks and either view compute or storage capacity. On the top right, you see the different storage tiers that you've created for your physical infrastructure and how much of that is already used or how much is available. So this is your main dashboard. You have the ability to create and define service catalogs. Again, your gold, silver, bronze service categories across your physical infrastructure. You have this provides the ability to create and define those service tiers. Again, this talks to UCS Manager and pulls any service profiles you might have already defined and identify and create service tiers. You have the ability to provision the physical infrastructure as a service from UIM. Again, the nice thing about this, it pushes down, it will pick the servers, the blades from the associated server pools. You've predefined and selected which OS is going to be installed. It'll install the ESX to it. It'll go ahead and provision the storage LANs. It'll zone them appropriately, assign them. From a networking standpoint, it'll assign the VLANs. It's really doing all of those orchestration items across the different physical infrastructure tiers to provision that service. Okay? And this is kind of the dashboard that walks you through the steps that it takes in order to make that infrastructure now available to your virtual infrastructure layer. Again, that's kind of the bottom stack, making it available to your virtual layer and your cloud layer. So that's kind of the provisioning aspects of the physical infrastructure. A little bit about service profiles, because that's an essential element. of the compute infrastructure in terms of providing a stateless compute model. The identity information for the blades is stored in what's called service profiles. It's kind of similar in concept to host profiles, if you're familiar with that. The idea here being that the blades themselves have no identity. The worldwide name, MAC, UUIDs, etc., are not associated. You define those characteristics within a service profile, and then depending on what identity you want it to take, you can essentially push down a service, associate a service profile to blades, and then it takes on that identity. Okay, so that's kind of the hardware provisioning and management stack. I'm going to kind of hand it over to Mahesh to talk about the virtualization and cloud stack.
I'll try this mic first. Can you hear me at the back? Probably not. Thanks, Rupan. Can you hear me at the back now? Hello? Can you hear me at the back? Okay. Continuing on, how many of you have seen Redwood or gone to the self-paced labs? Not many of you. I recommend going there because we have a good implementation of Redwood. It's a self-paced lab for 90 minutes, and you'll get a good experience on it. Introduction to vCloud Director. So this is the representation. On the left side, you see all the physical representation of the host, compute, SAN, storage, and networks. And what we have done there is we are using vSphere to consolidate into resource pool, data store, and port groups. And this you're pretty much familiar with. So now, as Rupan talked about, service level groupings of resources. So what we do here is this is the logical representation of your vCloud Director, how your vApps are going to lay out in this organization that belongs to a virtual data center, which is mapped on a resource pool. I'll go through that one by one here. So these are the components of the vCloud Director. At the bottom, you have the vSphere, which we are all familiar with. And then we layer vCloud Director on top of that. We have vShield, a component that gives you the perimeter security for your infrastructure. And we sent a chargeback. This is a separate product, which will allow you to do billing and other characteristics that you want to gather for your billing or showback purposes. And then we have Cloud API, which will allow you to provision using scripts or any programming languages you choose. So how do we do the provisions? So UIM was used to provision all your physical into vSphere constructs. Now, once we have done that, we have the other vCloud Director objects that we have to provision before we can install vCloud artifacts. So at this time, all the workloads, what we call as, must be pure virtual. What that means is all your vApps, they have no clue where they are residing. They only know that they are residing inside a virtual data center. And they have no clue about the host, the networks, or even the storage that they're running on. And they're all backed up by the service level business use case, where if they've already paid for a gold service, then they reside probably on a faster compute or a better storage performance characteristics. So we'll go through that one by one here. So I have created, let's say we have a 3 resource pool, silver, gold, and platinum, that was deployed already using UIM. And then we map that on to what we call as a provider virtual data centers. And these provider virtual data centers sit 1:1 on a resource pool. And so to provision a vApp, we need to create an organization. Let's see, we create a company called mycompany.biz with an organizational, and it can have multiple provider virtual data centers, which corresponds to your multiple resource pools, 1:1 ratio. And then within that, we create org virtual data centers. What that means is each of the service level provider VDCs can be carved out in turn and given out to your business units in an enterprise, or if you're a service provider, you can carve it out for users. And the user could be a startup or could be an enterprise themselves. So this will define how your vApps are going to map internally with what level of service you buy from the enterprise or from your service providers. And then how do they... And the third thing here is the catalogs. Catalogs, I'll just get into it in a little bit detail later, but they are basically like VMs which are templated. And then we need network pools. What this means is like we have virtual RJ45s lying around. So whenever you deploy a vApp, it needs to connect to the internal, maybe to another vApp internal to the organization, or may need external access. So these are lying around. Whenever you deploy a vApp, you can pick one virtual cable and attach to that vApp, and it'll talk to the either external or the internal networks. And then we have something called org networks. This is how the connectivity happens between the org VDCs and the external networks. So now we take a RJ45, connect org VDC ecom to a customer support, for example. So they can talk to each other internally without having traffic to go out. And e-commerce may have a web server, for instance, which may have an external connectivity, external facing websites. And then you can connect them to the external networks. So going a little bit deeper into the org VDCs, let's say we have this ecom org VDC with a certain characteristics of performance. So in this case, it was a platinum provider VDC. It probably has the highest 4 nines, highest IOPS, for instance, and never goes down. And we have 3 vApps deployed in this. So you can imagine this to be a database server, a middle tier, and a web server. And we can connect the web server to the external networks, maybe have a vApp middle tier connect to the external network using a vEdge appliance that we talked about earlier. It could be a router, provided some firewalling there. And finally, the database server connects to the internal network and only talks to the business WebLogic server, or business server. It doesn't talk to the external networks. So in this way, you can carve out your org VDCs in different ways so that you get your security as well as you maintain the level of service that you can provide. And certainly you can divide these vApps into different orgs as well, so that you can put the web servers in a DMZ as opposed to putting it in this org. So talking a little bit about catalogs. The catalogs basically are a collection of base OS templates. What I mean by that is you just install, like in vSphere, you would have a template, Windows 2008 template or a Red Hat's Linux templates. So we collect all that as a configuration and deploy those as one big template. So whenever somebody deploys, like you saw this morning when Steve Herrod was deploying an app, it comes pre-configured, and you deploy that, you get the same characteristics of the V template repeatedly without errors. And then they also come pre-configured. You can have those pre-configured with applications, for instance. So when you deploy that vApp, so you don't have to go and reconfigure those applications again. They also contain ISOs and floppies. So if you want to create a VM on the fly, then you can have those uploaded, ISOs uploaded. You can create a VM and then deploy those VMs as vApps. So vApps are the smallest unit of artifacts inside vDirector, but they contain VMs. Even if you have one VM, it's just one vApp. And you can assign sort of some properties on that vApp. And they all get propagated down to the VM levels. So how do we provision all these things? So we have covered some artifacts so far that we need to create before provisioning the Redwood, or rather vCloud director. So this is a GUI that you're probably familiar with now after seeing the presentation in the morning, is that we have 8 steps that you do to provision your vCloud director. So you attach a vCenter, and then you provide a VDC, which is already mapped to a resource pool. You create an external network if you want, so that you can have external access. And then you would create those virtual RJ45s in the 4th step, network pools. Then you create an organization like a mycompany.biz, and then go through the steps here to deploy. So this is doing through the GUI. Maybe initially you may have a need when you're very small to go through this GUI more often. But then after your environment grows big, you may want to try the orchestration. So we do have plugins to that with over 100 workflows through vCenter Orchestrator, where you can actually deploy your vCloud artifacts through that. And there is a good presentation tomorrow, 8030. One of our colleagues is going to give a deep dive in this presentation. You may want to try that. So in looking a little bit into the future, let's say your virtual resources are running out. There's a good chance that you can send a message back to the UIM and then have it provision more hardware for you. So it's not there today, but I can see that happening going forward. Similarly, when you have many resources that are not being utilized, you can sort of power them down and conserve. And the last option is to write your own portal to the vCloud director. We have several APIs that we have published. That is a part of DMTF. They are approved and by the DMTF organization, which means if you write these vCloud APIs, then you can port them to other hypervisors and it should work. We have a couple of extensions already on these APIs so that you can even do a sort of provisioning from Redwood into vSphere stuff. And we have over 150 REST API calls. Now, I'm showing here just the REST API calls, but there's nothing preventing you from using any of the language bindings to abstract the REST API. You can use Java, C#, Python, Perl, any of the languages that are available. And this is how it looks like, a little scary here, XML, but this is an example of how you would instantiate a vApp template. What that means is you have a template with a VM and you want to power that on, deploy it and power it on. So this is one of the XMLs that you would use. Again, you can use a Java binding or a C# binding, any of the other languages that you want to abstract the XML out and call it as a script or a program, part of a portal, many options. And finally, when you're done with all the provisioning and you have deployed your vApps, this is how it looks like. I've just deployed one vApp here with one VM, but this is how it looks like when you log into an organizational administrator. So the org administrators do not see other orgs, and they do not see the physical aspects, how it was provisioned. They only see certain things that they are allowed to see. And you can actually invoke VMRC, which is the VMware Remote Console, and look at your VMs deployed. Now, this can have external connectivity or not. It depends on how you set up your networks. And eventually, this is what happens when you deploy VMs. All said and done, we have the data stores. Up until vCenter, you can do a lot of these provisioning aspects from the UIM side. And anything below the vCenter, it's all the vDirector side. Some of the considerations for VCD on a Vblock is vSphere 4.1 or 4.0 update 2 is required. Certainly, Cisco supports the port group backed. Nexus 1000B supports port group backed network pools, the RJ45s, virtual RJ45s I was talking about. And for the other two types of network pools, we use the standard distributed switch. And this comes with the Enterprise Plus, as well, licenses. In conclusion, okay.
Yeah, so overall, we kind of walked you through the complete story in terms of provisioning a business service. The whole idea is in terms of pooling the resources. From a physical aspect, we're using Vblocks and UIM to orchestrate and manage those pools. The virtual resources and cloud resources, pooling of those is managed and orchestrated using vCloud Director and vSphere. The whole idea is to provide zero-touch infrastructure, automate the provisioning across the cloud, virtual, and physical infrastructure stack. You want to try to make things as efficient by automating as much of the repetitive tasks as possible. Vblocks provide that and are a good set of infrastructure in order to lead you down that path of stateless computing and zero-touch infrastructure. Self-service portals, again, policy-based provisioning at the vApps level through the portals available through vCloud Director. Being able to control, have the necessary availability, scalability, and security for your infrastructure by using the building blocks that vBlocks provide, right? The whole idea is to abstract yourself from all of the different component level details, worrying about putting and integrating everything together, making sure you have the right drivers and adapters, and does this work with this other piece? Get out of that business. You think about the system as a whole that's pre-integrated, tested, and works well. Okay? So that integration has been done for you, but it's open and extensible in order to plug into your existing infrastructure, your existing management frameworks that you have in place. The system as a whole can plug into that. There's a set of APIs available at each one of these layers to provide the extra glue that you might need in order to integrate and extend the overall capability. There's more things happening with VCE and the vBlocks in terms of automating and integrating all of the different elements. So look forward to seeing even more capabilities in terms of automation and orchestration within the vBlocks. Okay. A little bit about, there was a question about where can we get additional information. VCEcoalition.com is the site that you want to go to in order to download and get access to information related to the vBlocks. There are a few other sessions listed here that have similar topics of interest if that's an area of interest for you related to vBlocks and Cisco UCS in general. Definitely, I would encourage you to stop by the exhibition area. There's a whole area for VCE Coalition where you can speak to everybody that's out there to answer any additional questions you might have. Stop by the Cisco booth area where we do have a pod with UIM 2.0 also on display. On the show in the VMware booth, you can get your hands on Redwood as well. So definitely go to the exhibition area, attend the hands-on labs for getting some hands-on in terms of vCloud Director. So that's pretty much it. I'd like to kind of open it up for any questions, if there are any. Let's see, we still have some time. So, yes, please.
Yeah. Question on templates. Templates for any kind of auditing that's deployed. For example, if I'm setting up a test map, I want to provision for each one, and how many each one. Students for each three and so on. Set up an automated test map. So what kind of automation features you have?
Okay, so is your question on physical provisioning or on the virtual, or just across the stack?
On the virtual, the design part of the template creation, creating the template, what kind of features that you offer based on the templates that you follow?
So in terms of VM templates and creating those in terms of vApps as part of the service catalog, definitely you can create multiple templates for different service tiers of interest, and they could all be added to the catalog library. You can certainly, yeah, you want to speak?
You can also create public-facing catalogs. So in an enterprise such as, let's say, a big Fortune 500 company, you need specific catalogs across different business units. You can create that and make them public. So when a business unit comes and deploys vApps, they can pick and choose from the public or their own catalogs that they create. So there are ways to do that, catalogs. Versioning of the template, not now. Not in this version, it's not there. But a good point. Oh, before you forget, please complete the survey. That'll be helpful for us. Any other questions?
I guess the question is, can an org VDC cross a provider VDC?
No, the org VDCs cannot cross over from the provider VDCs for the simple reason that they are contained, self-contained within the provider VDCs. If you do cross, then you're actually you're straddling between two different services, which we don't allow today.
So that means that you have a vApps that is comprised of multiple VMs. One can't run on-premise and one off-premise.
Yes, but you can still have the connectivity between these two because they're all tied to the provider VDCs which sit on a resource pool, and the resource pool is tied down to the host. Unless you have host across private and public cloud, which is not recommended practice, you will not be able to straddle that between private and public. But you can still have vApps that are in the private cloud need access to the public cloud, and you can set up some sort of tunneling between those for connectivity. Okay, thank you.